Let's revisit the derivatives of exponential functions. Derivatives of exponential functions. And we'll begin by recalling the most basic derivative of an exponential function, namely the derivative of the natural exponential function. In fact, the derivative of e to the x power is just e to the x power. And so it'd be fantastic if, no matter what the base was here, e or otherwise, that we would exhibit the same behavior. But unfortunately, we don't. In fact, e to the x is the only function that does this, okay? So let's look at the derivative of any exponential function. This is the new rule that we're looking at here. So if I've got the derivative of some other base, if I have the derivative of some other base, let's call it b for base, b to the x power, well, it starts out the same way. So the derivative of b to the x, well, that's b to the x. But because the base may not be e, there's an extra factor on this that is the natural log of whatever that base is, okay? And so let's practice with this rule for a moment, and then I'll show you why that is the derivative. I should state a little bit about this base b. This only works if the base b is positive, okay? So you have to have a positive base for this. In fact, negative bases here cause all kinds of problems anyway, so we avoid those as much as we can. Okay, so let's see some quick examples using this rule. Well, let's start with the derivative of e to the x. Because this rule applies for any base that's positive. And of course, the number e is a positive base. So if we use this new rule on e to the x, well, we get e to the x, right? It repeats itself, right? B to the x, b to the x, e to the x, e to the x. But we have to multiply by this extra factor, the natural log of whatever the base is, which happens to be e. And luckily for us, because mathematics is so beautiful, the natural log of e happens to be 1. And so this does not contradict anything we already knew. The derivative of e to the x is still just e to the x. All right, so that's good news. But let's look at some others. How would you apply this in the case of the derivative of 2 to the x? Well, it's going to be 2 to the x. It repeats itself. But then it multiplies by the natural log of 2. Okay? In fact, you could think of the natural log of 2 as being maybe like a coefficient, because this is just a constant. You could type the natural log of 2 in your calculator, and you could get a value for that. Now, there's no better way to write the value than to write the natural log of 2, because it's an irrational number. If you tried to write the decimal, it would go on forever and not repeat. So that's all there is to this new rule. And as long as your base is positive, you can use it. Now let's look at why that's how you differentiate a base when it's not e, okay? And we're going to take advantage of some algebra that we know, along with the chain rule, in fact. So now we're just going to see why we can do this using knowledge that we already have. So if I want f of x, let's say, is b to the x power, then it would be very easy to differentiate if I could somehow change the base b to the base e. Well, the good news for us is that that's really not that difficult to do. You may remember from algebra that you could take a number like b and you could rewrite it as e to the natural log of b power. because e and the natural log are inverses, they cancel, and so this right-hand side just equals b also. Now, we may not be used to saying, hey, who wants to replace b with e to the natural log of b? Well, I do, because I want to do the derivative, and I can do the derivative if my base is e. So let's see how this works. So if I rewrite this, I can rewrite b as e to the natural log of b power. That's just the b part. I still have to raise that to the x power. Okay? And then, using properties of exponents, I know that I'd multiply. When you got an exponential raised to another power, you multiply the exponents. So this is the same thing as e to the x times the natural log of b. Now, I'm purposely putting my x first, because if I put natural log of b first and then do times x, you might think that it's the natural log of the argument b times x, which is incorrect. So we typically will put factors in front of the natural log to avoid that confusion. You can also manage it with proper use of parentheses, but we're avoiding the parentheses. So this, f of x, is equal to this function, which has a base of e. So now, if I want f prime of x, that's the same thing as the derivative, right? The derivative of this guy, e to the x times the natural log of b. And again, the good news here is that this is in base e. So how do you differentiate e to a power? Well, it's e to that power. So it's e to the x times natural log of b. But because the exponent is not just x, I have to implement the chain rule, and I still have to multiply by the derivative of the inner function, x times the natural log of b. Okay? Now, when I differentiate a constant, remember the natural log of b is a constant times x. Well, if I differentiate 2x, I just get 2, right? If you differentiate a constant times x, the x just goes away and leaves behind the constant. So here, the derivative of this, well, the constant stays and the x goes away. It's just basic power rule stuff, okay? So we end up with this guy. I'll leave that empty for now because we're going to call him something else in a minute. And then it's multiplied by the natural log of b, because that's the derivative of this. Now, what's maybe not as obvious is this guy here. This guy is the same thing as what we started with, which happens to be a funny way to rewrite b to the x. So let's take it back to the usual name that it carries. Instead of calling it e to the x times natural log of b power, let's go back and revert to, let's just call it b to the x. So we've got b to the x times the natural log of b. And so what we've seen here is if we differentiate this function b to the x, we get b to the x times this factor natural log of b. You can also see now why the base has to be positive, because you can only take natural logs of positive numbers. So without that, the thing would fall apart, okay? So that's the derivative of all the exponential functions with positive bases, besides just the natural exponential function.